so a lot of what we do in here is we're teaching people to observe what's happening around them. We want people to be able to, if they want to understand something, identify important questions about what they're trying to understand, and then learn how to observe things that help them answer their questions.
According to the American Modeling Teachers Association, the modeling method has been developed to correct many weaknesses of the traditional lecture demonstration method. Instead, it employs a student-centered instructional design.
Negative, but I notice you have a positive acceleration, so how does that match up?
Using this design, the teacher sets the stage for student activities with a demonstration and class discussion.
Throw this up, what happens to it?
It goes down.
Comes back down. What goes up?
It's up and down.
Must come down. Now we've actually launched a couple things in here, and when we launched them, we found that if we knew how long it was in the air, we go back and then calculate how fast it was going when we launched it. So we've done those equations, we're pretty comfortable with that. Today what we're going to be asking you guys to do is, alright, if I know how fast it's going, and I turn it to the side, can I figure out where it's going to land? And that's putting it all together, and that's our goal for today. So today, your first question to start off with is...
Then students plan and conduct experiments to answer the question. Lots of experiments.
My job my philosophy as my role as a teacher is basically, it's my job to help facilitate this learning process. And so a lot of what we do in here is we're teaching people to observe what's happening around them. We want people to be able to, if they want to understand something, identify important questions about what they're trying to understand, and then learn how to observe things that help them answer their questions. And this applies not just in science, it's in life in general. If you want to learn about something, you need to understand enough about it to ask the right questions, but then you also need to learn how to go out and collect enough evidence, data, however you want to describe it, experiences, so that you can adequately describe that phenomena and then bring it back into your understanding of the entire world around you.
After collecting data, students are required to present and justify their conclusions in an oral, written, or digital form.
Well, in the first quadrant, there was questions about whether the angle affected whether the target would get to, or the object would get to the target. And for the first simulation, the angle was 0, that worked, and the velocity didn't matter. For number 2, the angle was 41, and the velocity didn't matter either. Then we calculated some times and the x and the y. And for these questions, about the horizontal velocity, if that changes. And for number 4, is if the angle changes, does that affect the distance?
The modeling method engages students in understanding the physical world by constructing and using scientific models to describe, to explain, to predict, and to control the physical phenomena. These physics students are doing amazing things, but just how effective is the modeling method? Research conducted by the National Science Education Leadership Association and Arizona State University concludes that high school students under modeling instruction average more than 2 standard deviations higher on the FCI, a test designed to measure learning progress with the modeling method.
The idea that we keep learning for the rest of our lives is something I hope to inculcate to my students, such that for the remainder of their lives they can also take confidence in the fact that they can be learners and can become better learners, and that they can learn whatever they need to learn.